Hello students, welcome back to my channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we'll discuss the lab exercises on analog to digital and digital to analog converter circuits. This is the list of experiments which will be performed in this part. We have one experiment on analog to digital conversion using flash converter. Then two experiments are on digital to analog conversion, weighted binary method and R2R ladder network method. The last experiment is on binary code conversion and it will be performed in virtual lab. The next assignment is binary code converters. This experiment is performed in the virtual lab. This is the address of the lab, and these are the four converters which are observed in the lab. And with the help of truth table of all the converters, the working of the converter circuit is verified. Let's go to the virtual lab of electronics and communication engineering and click on Digital Electronics Lab 1 New. Here in the list of experiments, we'll find binary to gray and gray to binary code converter circuit using NAND gates. So we'll click on that link and we can go through the theory part of binary to gray code conversion. Right. Normally exclusive OR gates are used for conversion. So we are implementing exclusive OR gates using NAND gates. This gives the procedure of the experiment, and now by clicking on simulation we go to binary to gray code conversion. You can see here these red switches are indicating the input. Presently the input is 0. The battery is connected. When we click on this switch it will go from 0 to 1, right? This green, and output green indicates 1, input red indicates 1. Input black indicates 0 and output white indicates 0. So by changing the switch position we can observe the output and we can add it to table for different values of the input. We'll go on adding it to table. The table entry contains the binary value which we have selected and the corresponding gray value which is obtained at the output. This way the table will be created and at the end we can observe the table entries to see whether the conversion is correct or not. We are changing the input switches, observing the output and adding it to the table. Now the table can be observed for the all input values which we have given and the corresponding output gray code is observed and the circuit is working correctly as binary to gray code converter circuit. Now we can go to the previous screen and we'll see another circuit, that is gray to binary code conversion. Just click on that. Now again we have to follow the same. We have to click on the battery so that it gets connected, and then we have to go on adding values for the given input. For 0 0 0 0 output is 0 0 0 0. So let us add this value. Now for 0 0 0 1, right, output is 0 0 0 1, you can observe here. Now 0 0 1 1 gives output 0 0 1 0. Take another value 0 0 1 0 at the input, output is 0 0 1 1, which is added to the table right now. Again we can complete all the entries here for the given input value and we can observe the output, and this circuit will convert the gray codes to the binary equivalent values. Let's see the table. All the entries in the table show that the circuit has converted the gray codes to the equivalent binary values. We have added one more value here. Even there is a print command in the observation. If we click on that command, then we can save the result as well. So clicking on the print command, we can save the PDF which saves the circuit as well as the table. This way the circuit is tested and verified. Let's go to another lab, that is hybrid electronics lab. As such, we can observe so many digital labs are there. In hybrid electronics lab, we'll find more converter circuits here. So let's go to list of experiments and go to code converters. In code converters, you can see that 4 types of codes are supported here. The procedure gives us the procedure, and when we go to simulation, in the simulation window we have gray to binary, binary to gray, BCD to XS3 and XS3 to BCD code. So binary to gray and gray to binary is already done, so we'll go to BCD to XS3 code, and in this lab we have to give the input and output is observed and truth table is already given. So we just have to verify whether the output observed is correct or not. Even the waveforms are given for BCD input and corresponding XS3 output. At any time we have to adjust the switch positions and press run. For each input we have to press run at the output. So for each input, when you press run, it gives you input as well as the corresponding output, and we can observe it and verify it from the table. For all zeros, the output is 0, 0, 1, 1, right? For 0, 0, 0, 1, press run again, and the output observed is 0, 1, 0, 0, right? Similarly, we can press other inputs 0, 0, 1, 0, right? Now press run. We have to press run to change the output. It is 0, 0, 1, 0. Run gives us output as 0, 1, 0, 1. That way we can do this experiment for all combinations of input, and by pressing run we can observe the output and verify it from the truth table whether the circuit is working properly or not. This way BCD to XS3 code converter circuit or the BCD to XS3 experiment can be performed. So this is the last value, all ones. When we run it, it doesn't give us any output. Why? Because this code is invalid in BCD. We do not have 1111 in BCD. The code in BCD, valid code in BCD is 1000 or 1001, right, up to 9. And so we get output only up to 1001. So this way we have performed BCD to XS3. Let's go XS3 to BCD code converter circuit. We have to perform the experiment similarly the way we did it for the previous experiment. This gives the waveforms for the patterns of the input. So all zeros run 0, 0, 0, 1. Run. It's not running. Why? Because the first value is 0, 0, 1, 1. For XS3 code, the first value is 0, 0, 1, 1. So we have to start with 0, 0, 1, 1. Right? Now run. It will give us a value of 0, 0, 0, 0 as the BCD code. Right? So we have to check the truth table and accordingly we have to give input. This is 0, 1, 0, 0. So it will be 0, 0, 0, 1 for the BCD code. So we'll go on checking the truth table and we'll go on putting those values here. It is 0, 1, 1, 0. So it gives value as 0, 0, 1, 1, right? So we can observe it in the truth table that the circuit is working correctly. You can observe the gates which are connected in the circuits to produce these outputs for XS3 to BCD code conversion. This way this experiment is performed and it is verified from the truth table that the circuit is working correctly as XS3 to BCD code converter circuit. I hope you have understood the working of the given circuit. Thank you.